In this tutorial, we are going to create a fully functioning digital clock. Let's take a look at the finished results so you know what you will be making. The digital clock has almost the same controls as the analog. You can set the start time using these custom properties, and when you play the animation, the clock starts ticking. And just like with the analog clock, you can move the entire clock by moving the empty. The speed controls works a bit differently in this version though. Here you don't have to worry about the current frame rate. Instead, a value of 1 is always real time. A value of 2 makes it go twice as fast, and a value of 0.5 makes it half as fast. Much easier to understand. But other than that, the only major difference with the digital clock is that it has a different way of displaying the time. Let's set the start time to 23:59:56, right before everything becomes 0 again, just to see what it looks like. Just like a real digital clock. So, let's get started. We will create the digital clock by modeling every single digit and then quickly switching between them depending on the current time. The easiest way to do this is to have all the digits in different rows and then move the rows to the right location. Let's make this a bit easier to understand by simply creating one of the rows right away. We will start by creating a single digit. Remove the default objects, add a plane, enter edit mode, and rotate it 90 degrees around X. Scale it 0.5 so it gets a height of 1, making it easier to do math on later on, and 0.5 along X, making it rectangular. Let's give it a dark material. We could use textures to make the digits as detailed as we want, but since this tutorial is about the functionality of the clock and not the look, I'll keep it simple and create them using different materials on different faces. To get enough faces to create the digital number look I want, I will add 6 loop cuts along X and 10 along C. Add a new material with a slightly brighter gray. We will use it to mark the areas that can turn on or off to create different digits, just to replicate the look of a real digital clock. So select all faces used to create the different digits and assign the new material. With one digit done, add an array modifier. If we now set the count to 10, we get enough to create all the different digits from 0 to 9. We want the row to be vertical instead of horizontal, since we are going to move this row up and down to change the current digit. So remove the X offset and set the C offset to -1. I set the offset to -1 along C so the row points downwards, since it makes it easier later when we are going to drive it to show the correct time. Now when we increase C, we move along the row from the first to the last digit. With the row done, let's apply the array modifier so we can make each digit different. Add a new white material. We will use this to paint the actual digits. Let's quickly change it to an emission material so the display actually casts lights when we render it. Now I will just go through and select every face that will make up each digit, starting with 0 at the top, moving my way down to 9. With all the faces selected, assign the white material. We now have a row with all the different digits from 0 to 9. Let's rename it digitrow.000. This entire row will now be the first digit out of 6 in our display. Let's create the rest. Make a linked duplicate. We always want all digits to remain identical, and move it -0.05 units along X so the two rows are edge to edge. We now have the two rows that will display the number of seconds. I named it .000 so the naming remains consistent when I duplicate it. Now the new copy is called digitrow.001 instead of adding a new number to the end of the name. To get the digits for the number of minutes, select both rows, link duplicate, and move them -1.2 units along X so we get a small gap to separate the two sections. And repeat once again for the number of hours. I moved the new copies from left to right because I want the first row, .000, to be for the number of single seconds, moving from the smallest to the largest value. And now we have the number of hours, minutes and seconds. Great. It might look a bit chaotic with all of these digits, but don't worry. When we are done, only 6 of these will be visible, one from each row showing us the current time. To complete the display, let's fill in the areas around these digits. I want to have colons between our set of numbers, so let's start with that. Add a plane, rotate it 90 degrees around X, and scale it 0.5 so it gets the same height as the numbers. Scale it 0.2 along X to give it a width of 0.2, the same as the distance between the sets of digits, and move it minus 0.85 units along X so it fits right between the two sections. Give it the same dark material as the background of the digit rows so it looks like everything is one object. To get enough faces to create the actual colon, we need to add some loop cuts. 2 along X and 10 along C. Select the faces where you want the colon to be and assign the white material. Since I know that I will only need 2 colons, one on the left and one on the right, let's rename the object colon.r for right. We want an identical colon in the other gap, so make a linked duplicate and move it minus 1.2 units along X so it fits right between the second set of numbers, and rename it .l. Now the display meshes are almost complete. Let's just add some more empty space around the edges. Duplicate the colon object, move it to the side, and remove the white material so the colon disappears. Rename it displayEdge.r. Link duplicate it, move it to the other side, and change it to .l. And now we have all the geometry we need for the display. Just like with the analog clock, we will have one object that holds the current time and use it to drive the rest of the clock. However, unlike the analog clock, I won't keep the time by using the position of an empty. I did that to make the passing of time more visual, but a value that is just used behind the scenes can be replaced with a custom property. The last time it didn't really matter if I did it through the position of an object or a custom property, since we just needed one value. But this time we will need 7 different time values, so if we were to do it the same way as the analog clock, we would have to add 7 empties. So instead I will add them as custom properties to a single empty. Add an empty and rename it time. Let's move it to the side so it's not in the way. Add a custom property and name it current time. This property will act the same way as the position of the time empty did in the analog clock. Increase the maximum to something high so it won't interfere and click OK. We want the current time property to adjust itself automatically, so add a driver to it. Open the driver window and set the expression to just frame. If we wanted the clock to go real time, we would have to divide frame by 30, our current frame rate. However, having to move 30 frames in the timeline for a 1 second difference will make it really tedious to test if things are working, especially when we start working with hours. Therefore, I will keep the speed of the clock at 1 second per frame for now. Let's set the start frame to 0 so the current time is 0 on the first frame, and set the end frame to the maximum so it won't interfere. Now we are going to use the current time property to drive the C location of all of our digit rows so they show the correct time. For example, when we have a time of 4 seconds, the first row will move 4 units up, making the 4 line up with the display. I won't drive the location of the digit rows directly using the current time. Instead, I will add a layer in between with different custom properties that holds the values the different rows should be displaying. The current time property will drive different custom properties, which in turn will drive the location of the rows. I do this because I want the calculation of time and the way we choose to display that time to be 2 separate parts of the clock, which will make it more flexible compared to if we have it all mixed in one place. So, add a custom property and rename it seconds single. This will hold the value the first row should display, the number of single seconds. Increase the range here as well so it won't interfere. Let's create one custom property for every row. The number of 10 seconds, single minutes, 10 minutes, single hours, and 10 hours. Notice how I named them with their common word first, hours, minutes, and seconds, so they get grouped together in the list. Let's quickly change them all to 0 so they don't have any value by default. With the 6 custom properties added, it is time to make our 6 rows of digits listen to them. Add a driver to the C location of the first digit row and set it to use the raw second single property. And now when I adjust the second single property, the row moves accordingly. Entering a value of 4 makes the row show a 4, and entering a value of 9 makes it show the number 9. However, if I set the value to 4.5, it is moved to right between the number 4 and 5, not what we want. Since this is a digital clock, it should stand still on every digit until it instantly switches, instead of moving smoothly between them like it currently does. To make it stop on every whole second, we can use the same trick as we used on the analog clock. That is, to remove the decimals using a floor function. Since this has to do with the displaying of time and not the actual time, I will add it to this C location driver instead of any of the time properties. And now it moves one number at a time when I change the second single property. Let's add this moving functionality to every other row as well. Copy and paste the driver and change the variable to their corresponding property. Seconds 10, minutes single, minutes 10, hour single, and hours 10. Now all the rows listens to their respective time property. Great. So, all we have to do now to make the clock show the correct time is to drive these different time properties using the current time. Let's go from small to big, starting with the seconds single. Add a driver to it and change the default variable to use the current time. The row should simply move one number every second, so set the expression to var. And now when I drag along the timeline, the number increases automatically. However, it should start over at 0 again after it reaches 9, but right now it just continues upwards forever. We can fix this by adding a modulus. Since it is never supposed to reach 10, I will use modulus 10. And now when I scrub the timeline, you can see that it starts over like it should. The first time property is now done, so let's move on. The next one is the number of 10 seconds. To save some time, we can copy and paste the driver from the second single and adjust it. Instead of moving one step every second, we want it to move one step every 10th second, so divide var by 10. Although it's not necessary due to the order of operations, I'm adding brackets around the var divided by 10 so it is clear that it is done before we calculate the modulus. And now it flips to a new digit whenever the second row starts over. However, since the clock should never display 60 seconds whenever we want it to reach 6, it should start over after 59. We can fix this by changing the modulus from 10 to 6. And now it is starting over after 59 seconds. Copy the seconds 10 driver and paste it to the next one, minutes single. We want it to move one step every 60 seconds, so change it to divided by 60. Here we want a modulus of 10 again, since we want it to reach 9 before it starts over. The next one is minutes 10. Paste the driver. We want this one to change 1 unit every 600 seconds, 60 times 10, so divide var by 600. And since it should start over again after 59 minutes, we will leave the modulus at 6. The next one is the number of single hours. We want this one to increase with 1 unit every 3600 seconds, 60 times 60, so divide var by 3600. Since it should be able to reach 9, change the modulus to 10. The last one is the number of 10 hours. We want this one to change every 36,000 seconds, 60 times 60 times 10, so divide var by 36,000. We can ignore the modulus on this one for now. And now the clock works great. However, what happens if we move the current time to beyond 24 hours? It should start over at 0, but as you can see, it doesn't. You might think that we could fix this by just adding a modulus 3 and 4 to the hour rows, making it start over after 23, but that won't work. The number of single hours should be able to reach 9 for both 0 to 9 hours and 10 to 19 hours. Only after it reaches 20 should it be limited to a 3. And the number of 10 hours has to flip to a 0 well before it becomes a 4, since the day doesn't start over at an even number of 10 hours. The easiest way to fix this is not to do anything with the display of time, but with time itself. If we make the current time property start over using a modulus, all numbers will start over at 0 like they should automatically, without having to worry about the individual digits. There are 86,400 seconds on a day, 60 times 60 times 24, so we will add a modulus 86,400. If we want to, we can remove the modulus from the 10 hours driver since it will never need to restart on its own. And now the clock starts over again after 23:59:59. Great. Now when the displaying of time is working like it should, we don't need it to move fast anymore for testing. So let's change it to go real time. Right now it only says frame, making the clock take 1 second for every frame. We can make it go real time by dividing it by our frame rate, 30. And as usual, I add brackets even though it's not necessary, just to make it easier to see what is happening. And now 1 second takes 1 second. However, putting in a concrete value of 30 is not ideal, because if I change the frame rate of the scene, the clock won't show the correct time anymore. We need to add something that adjusts it according to the current frame rate. In the analog clock, we avoided this by adding the frame rate adjustment to the speed control, making the user adjust any changes manually. But for this one, let's try grabbing the information directly from the scene instead. To do this, go to the render settings and hover over the frame rate value. This doesn't show the path to the frame rate property since it is just a list of presets. To get the actual frame rate property to show, we have to select custom in the list. Now the property is visible and we can hover over the 30 to see the path. Scenes, scene, render.fps. So let's add this information to the default variable. Scene, render.fps. And now the variable has a value of 30. Let's rename the variable FPS and change the expression to frame divided by FPS. And now, no matter what frame rate I choose, the clock will always have the correct speed. Well, almost at least. Below the frame rate control, we also have a frame rate base. Changing it changes the current frame rate. You can see the resulting frame rate here in the preset list. Making it 5 times as big makes the current frame rate 1/5 as big. So, we need to divide the FPS variable in our driver expression by this frame rate base. Just copy the data path, add it as a variable, name it base, and divide FPS by base in our expression. Put it in brackets since we want to divide the FPS with the base to get the correct frame rate before we use it to divide frame. And now the clock will have the correct speed no matter what frame rate our scene has. Since the clock can take on its own now, it is time to add the manual controls. Like with the analog clock, we want to add these controls to the object we will use to place the clock so everything gets collected in one place. I won't use the empty we already have since it has custom properties that are driven, and I don't want them to be visible to the user of the clock. If the user can't change a property or need to see its value to be able to adjust something else, the user should not see it at all. So I will keep this time empty only for the hidden controls and then add another empty for the controls that should be visible. Move the cursor to the center, add an empty, sphere so it stands out from every angle, and rename it clock. We will place it on the side for now so it isn't in the way. We can easily give it the correct center position later. Now let's add the custom properties hours, minutes and seconds so the user can manually adjust the start time of the clock. Set them to 0, removing the decimals at the same time, and give them their appropriate range, 0 to 23, 59 and 59. Go to the current time driver and add the new time controls as variables. The expression for changing the time will be the same as for the analog clock, since the actual time calculation is identical. The only difference is the inclusion of the modulus for making it starting over after 23:59:59, which the analog clock does automatically due to its design. Since we want the clock to start over after 23:59:59, regardless if the time comes from the timeline or the manual controls, we want the modulus to be added last. So, add the two brackets and move the modulus away a bit, making it easier for us to focus. First we have seconds, which we just add since we want to add 1 second for every second. Then we have minutes. There are 60 seconds in 1 minute, so write plus minutes times 60. Finally we have hours. There are 3600 seconds in 1 hour, 60 times 60, so write plus hours times 3600. And now I can pick any time I want as the start time. Let's move on by adding a speed control to the clock empty so the user can pick the speed of the clock. Set the range to be as big as you want. Instead of just making the maximum value big, let's also change the minimum to a large negative value. That way, the user will be able to make the clock go in reverse. With the control created, add it as a variable in our current time driver and name it speed. Unlike the analog clock, the speed control is independent from the current frame rate, since the current frame rate is already taken care of in the driver. That makes the speed control very simple to add to this expression, since we just need to take whatever time the clock currently has times the speed. We don't want the speed to affect the start time chosen using the manual controls. We only want it to affect the time that comes from playing the animation, so multiply this current frame calculation by speed. And now it is working. Keeping it at 1 makes it go real time. If I set it to 10, it goes really fast, and if I set it to 0.1, it goes slow. And since the modulus is added last, the clock always restarts when it should. I can even set a negative value to make the clock go in reverse. Since we are using multiplying instead of dividing, we don't have to do anything to stop the property from getting a value of 0, like we had to do with the analog clock. If we write 0, the clock just remains at 0 forever since it doesn't move. And if we increase it, it starts moving again. Now the user has complete control over the current time. Great! Now the logic of the clock is working, so let's work on the look of the display. We really don't want to see any other digits than the current time. Seeing the rest of the digits ruins the illusion of a digital display, since we see it as motion up and down instead. If we adjust our view so we can't see the top and bottom of the clock, it stops looking like movement and starts looking like a display switching between numbers. This is what we want to achieve. We can get this effect by hiding every other digit except for those that isn't part of the current time. This can easily be done by using a Boolean modifier. A Boolean modifier compares two meshes and gives you the difference between them. What this means is that I can use a mesh to cut away a piece from another mesh. So what we want to do is to create a mesh that covers every digit except for those that should be visible. Then we add a Boolean modifier to the digit rows so everything except the number in the center will be removed. So add a cube, name it display bool, and move it -1.45 along x to place it in the center of the display. Enter edit mode and adjust it so it covers every digit below the line in the center. Make a tiny bit of an overlap into the digits that should be visible just to be sure, so there won't be any gaps even when they are in the highest position. We want an identical mesh above the display as well, since the rows will move upwards, so add a mirror modifier and change it to use C. And now we have a mesh that covers everything that should be invisible. Apply the modifier. Now, for the display to be complete, all we have to do is to add a Boolean modifier to our digit rows and set our new mesh as the Boolean object. We will start with the first digit row, add a Boolean modifier, and add our display bool object. To remove the numbers you don't want to see, select Union. It looks like nothing has happened, but that is just because the Boolean object is still visible. If we turn off its visibility, both in render and viewport, we can only see the single digit in the first row. And when we scrub the timeline, it looks like it flips between different digits. We can quickly add the same modifier to the rest of the rows by selecting them all, the one with the modifier last, and link modifiers. And now we have a working display. We could add the Boolean modifier to our columns and edges as well to quickly make them match in height, but that won't be necessary since the edges will be covered by a clock cover. Let's add it right away. Add a cube, rename it clock cover, and move it -1.45 along X to place it in the center of the display. Grab the front face and move it 1.5 units along Y so everything is behind the display. Scale it 2.25 along X to make it wider, and 0.8 along C to make it a bit lower. Add 2 loop cuts along X and scale them so they just cover the edges of the display. Do the same on C. Now select the newly created faces around the edge of the cover and extrude them outwards by 0.7 units so they cover the edges of the display. Finally, give it a brown color. And now the look of the clock is complete. There is a big issue that we can't see here in the viewport that stops this clock from being used in an actual animation, and that is that it has no proper support for motion blur. If you don't render with motion blur, then by all means this clock is ready to be used in your video. But if you do, it needs some changes. A digital clock should never be blurred when it switches numbers. This clock, however, has moving parts, quickly swapping each number. This is what it looks like rendered. As you can see, on every number change, the digits gets completely blurred, not how it is supposed to be. I decided to show you how to create this flawed version first, because it is much easier to create and understand. Also, if you don't need motion blur, it does work well. But now when we have a better understanding of the display concept and how it is working, we can easily change it to the better version. So, to stop this motion blur issue, we need to find a way to swap digits without actually moving anything. We will do this by keeping every digit as a different object and then just show the digit that should be visible and hide the rest. Since we won't have rows of moving numbers anymore, we don't need the display bool object, so we can delete it. Let's also hide the cover for now by moving it to another layer so it's not in the way. To combat this motion blur issue, we only need to change from our moving rows of digits to several separate digits we can hide and show. We don't need to change any of the actual clock logic. Here we can see the benefit of keeping the logic of the clock separate from the way that information is displayed. To create those hiding and showing digits, let's delete all linked duplicates of the row of digits and just focus on the first one. We don't want this mesh to move along C anymore, so remove the driver. And we don't need the Boolean modifier, so remove that as well. Now we want to turn this row into 10 separate objects, one for each digit. This is very easy to do since they are all separate parts within the mesh, thanks to us not activating merge on the array modifier when we created them. So we can just separate by loose parts and we get 10 different objects directly. Very easy. With all of them still selected, apply the origin to the geometry so all of their origin points are moved to the center of each digit. Now we need to make them show or hide depending on the current time. We are going to do this using a mask modifier. It is a modifier that allows us to hide certain vertices using vertex groups. The benefit of using a mask modifier instead of hiding objects using the outliner is that the object is still available for us to select and work on. It won't disappear from the viewport, its geometry will just be invisible. Add a mask modifier to the 0. It disappears. Since we haven't chosen a vertex group, it automatically chooses every vertex. If we press this little double arrow, we invert the selection, choosing no vertices, making the digit visible again. We are going to add a driver to this double arrow so we can toggle the visibility. The advantage of driving this double arrow instead of the visibility toggles of the modifier itself is that we can change its visibility everywhere with just one driver. If we were to drive these toggles, we would have to create a duplicate driver for each toggle. So, add a driver to the invert button and add the second single as a variable. The expression shows the value it had before we added a driver. It says true. Since this button is a toggle instead of a number, it can only have two values, either true or false, on or off. True and false is just a fancy way of writing 0 and 1. Writing true in this box gives us a value of 1, and writing false gives us a value of 0. So if we write 1 instead, the double arrow is activated, and if we write 0, it is not. Any value of 1 or higher will activate the toggle, and any value less than 1 will deactivate the toggle. For example, a value of 10 will activate it, and a value of 0.99 will deactivate it. Since we just want this to be on if a certain condition is true, we are going to use a comparison operator. If it is true, the digit should be visible. If not, it shouldn't. So, what we want to check is if the second single is 0 or more and less than 1. If so, the digit should be visible. Since the value can never be below 0 due to the modulus, we can just check if it is less than 1. So let's write var less than 1. Now this expression is comparing if var is less than 1. If it is, it returns 1, turning the invert toggle on, showing the digit. If it is not, it returns 0, turning the invert button off, hiding the digit. Now when I drag along the timeline, the 0 digit is only visible during the first second, and shows up again after 10 seconds. Great. Let's add a mask modifier to all the other digits as well. Select every digit with the 0 last, and link modifiers. Let's continue with the 1 digit. The drivers didn't get copied with the modifier, so copy the driver from the 0 and paste it to the 1. The expression for this one is a bit more complex since we have to check two things. It has to be 1 or more, but still less than 2. We can do that using two comparisons in one. Var bigger or equal to 1 and var less than 2. Now it becomes true only if both of these are true, only showing the digit if var is bigger or equal to 1 and if var is less than 2. Let's add this mask modifier toggle to all the other digits. Copy the driver and paste it to the rest. Now we just need to go through and adjust the numbers in the expressions to correctly reflect the digit the object is showing. Since I copied the driver from the 1 digit, all digits are currently only visible between seconds 1 and 2, so make sure you are on a frame where you can see them all. The 2 should be visible between 2 and 3, the 3 between 3 and 4, 4 and 5, 5 and 6, 6 and 7, 7 and 8, and 8 and 9. For the last one, we only need one condition, just like for the first, since the second control can never go over 10 thanks to the modulus. We don't have to check if it is too big, so write just var bigger or equal to 9. And that's it. Now the right digit is always showing when I drag along the timeline, going from 0 to 9. With one row done, we can duplicate it to create the other rows. But before I do that, I will take the time to rename all the digit objects. I will name them digit row, the digit they display, .000. That way you can clearly see what digit each object display, and when I copy the row, the naming will stay consistent automatically. With the renaming done, we can start duplicating the row. Select all objects in the first row by using the circle select and dragging where they are. Here we can see the benefit of using a mask modifier instead of actually hiding them. We can still select and manipulate them even when they are not visible. Create linked copies since the digits should always remain identical, and start placing them in the same locations as we had the rows before. And done. Since some of these numbers will never be visible due to the modulus restarting them, we can delete some of them. In the row of 10 seconds and 10 minutes, the digits 6 to 9 will never be seen since they start over after 5. So we can select those and delete them. The same goes for the 10 hours row. That one will never show numbers 3 to 9, so let's delete them. Since every digit now has a driver with the correct expression for the digit they display, all we have to do to make these rows work is to change the variable to use the correct time property for each row. This can quickly be done by selecting all digits in the same row so all drivers pop up in the driver window at the same time, and then change it for all of them by going from top to bottom. Copy and paste it to make it even quicker. Minute single. Minutes 10. Hour single. And hours 10. Now all digits are showing and hiding like they should. All we have to do now to complete the display is to move all digits of each row to the same location so it looks like they are all the same objects. Since the origin point is already in the center of every digit, it is very easy to move them to the same location. Select the first digit, the 0, and move the cursor to selected. This is the position we want all digits of the first row to have. Select the other digits in the row. With all of them selected, move selection to cursor. Now all the digits of the first row are in the same location, so when we play the animation, it looks like a digital clock switching numbers. Great. Let's move the digits of the other rows to the same location as well. Move the cursor to the location of the 0 and move the rest of the digits to the cursor. To make sure we didn't miss any digit, we can select all objects and make sure that there are no object origins outside of the display. And now the display is complete again. Great. Now it is time to add the final touches to the clock. Let's unhide the clock cover and at the same time move everything to the same layer. Now all that is left to do is to parent everything to the clock empty. Before I parent anything, I will place it in the center of the clock. Select the top and bottom faces of the clock cover and move cursor to selected. Then select the clock empty and move selection to cursor. Now the empty is right in the center of the clock. Let's select all objects we want to parent to the empty. This clock consists of a large amount of objects, so the easiest way to do this is to select everything and then deselect the few things we don't want. However, in this case, there are no objects we don't want to be parented. Just like with the analog clock, the time empty doesn't have to move around to do its job. It can stay where it is. However, it doesn't hurt if it moves around with the clock, and parenting it will place it under the clock empty in the outliner, making the scene more organized. With all the objects selected, make sure the clock empty is the active object, and then parent. Now you can see how clean the outliner got, showing just one single object, the clock. We can now reset the location of the clock empty, and the clock gets centered in the scene. We don't have to see this time empty anymore, so let's hide it. Let's also turn off viewport selection for every object except for the clock empty, so we don't grab anything else by mistake. We have a fairly long list of objects here, so it is good that we can click and drag. And now you can only select the clock empty. And that's it! This concludes the tutorial on creating a digital clock. I hope you have learned something. Thanks for watching.